All right, let's get started. So this session today, we're going to be talking about AutoML. My name is Kunal Batra. I am a senior developer advocate here at AWS. If you're not familiar with what a developer advocate does, essentially it's just an engineer who helps build awareness and adoption. I worked on many different developer-focused verticals in my career. If you have any questions on any of those, feel free to reach out. You can reach out to me, my Twitter handle at Kunal732, or my email, kbatra@amazon.com. And also, I'm just personally also really into machine learning and specifically computer vision. On the bottom left of that slide over here, there's a model I built that lets you know whether the garage door is open or closed, simple image classification there. Another one right to the right of that, object detection. It actually counts how many people are in line at the Shake Shack in Madison Square Park. This is pre-COVID. And then last, another real fun one here, a simple object detection algorithm, some household items I have around the house. So this is just a passion of mine as well. If you have any questions on anything you see in this presentation or something else that I worked on, feel free to reach out. All right, so the agenda for today, we're going to be going into, again, a little bit of what machine learning is, and then from there, kind of walk you through how AutoML helps with that if you're not a machine learning expert, and how it does some of that heavy lift, takes care of the heavy lifting for you. We'll go into two of the tools and services that we have over here, Autopilot and AutoGluon, that can help you with AutoML. And then after that, I also want to showcase some other ways to add that intelligence to your applications if you don't want to train your own models. There will be demos towards the end. Okay, so let's just really recap here and level set for the audience the difference between AI and ML. And artificial intelligence is any sort of computer system that can mimic human behavior. It doesn't have to be neural nets. It could be a bunch of if and else statements. However, once we start talking about machine learning, now we're talking about learning from that data and being able to get a result. Results can be recommendations, forecasts, predictions, and more. But essentially, we're trying to use that data and produce a program that can perform a task. So there are different types of machine learning algorithms. Two of the more popular types of machine learning algorithms are supervised learning and unsupervised learning. So when it comes to supervised learning, you require the inputs as well as the outputs. So for example, that model I built earlier that I showed you with the garage door open or closed, if you want to build an image classification model that'll be able to tell you if the garage door is open or closed, you need a training data set of a bunch of photos where the garage door is open and you need to label that open, and then another set of photos where the garage door is closed in different scenarios, daylight, nighttime, and then again label that as closed. So then you have that. Supervised learning essentially means you have both the input and output data ready to go. Unsupervised learning, you only need the input data, and then you can do things around that as well, and we'll talk about that in a second. So when it comes to the categories of supervised learning, you can do classification. Again, garage door open or closed, that's essentially binary classification. You can also do multi-class classification as well, red, blue, green. You can do regression. So this is a continuous value that's used for forecasting. It can tell you temperature, stock prices, etc. Now, when it comes to unsupervised learning, you can do things by like taking a look at the similarity of the attributes of your inputs, and then you can cluster that based on the similarity. So just a couple more examples here. For classification, again, you can take advantage of things like your accelerometer and your gyroscope and your watch and see if you're you're on the steps, stairs, sitting down. For regression, that is forecasting for financial forecasts or resource consumption forecasts. You can also do, again, like I mentioned, for unsupervised learning, looking at the attributes of your inputs and clustering based on similarity. In this case over here, you're taking a look at data points for the vehicle speed of a car and also the RPMs of the car, and then you're able to see what gear the car is based on that. So machine learning, there are lots of different types of algorithms that can get you the results you want. And this is an art, right? Sometimes you can have two different algorithms that can get you the right answer, but how do you know what works best, right? And this takes a lot of experience and past and iterations to figure that out. So just a quick view on this process, right? So the first thing you want to do in the ML process is you want to figure out how do you frame your business problem into a machine learning problem? Is this going to be classification? Is this going to be supervised learning, unsupervised learning? You need to figure that out. The next step over here is data collection. You need to be able to gather that data from multiple sources, integrate it into one set of data that you can feed in. From there, you want to be able to make sure you can prepare that and clean it, take out any duplicates if there are any, and then you want to analyze that data, make sure that you have the right pieces of data to solve your problem. Maybe you want to augment that with some other data. From there, you want to be able to choose the correct features that you're going to need for your training. Once you have that, you're going to go ahead and start training that model, tuning the parameters. You're going to evaluate how well it does and how accurate it is. If that does meet your business goals, you can go ahead and deploy it. If not, you can kind of start that process again, back from data collection all the way to model evaluation until you get the results that you're looking for. Once you do deploy it, you can start seeing predictions with real life data. Now, if there's issues with that real life data and it's not giving you the exact level of accuracy that you want, you can go ahead and then again start the whole retraining process as well. So this is an art. This is not a linear process. This is very iterative. Now, when it comes to AutoML, it takes care of a lot of that heavy lifting for you, right? So anything with a star here is what AutoML can help out with, right? So anything from the data prep and cleaning to the feature engineering, to that model evaluation, to actually that monitoring and debugging, see how well it's doing, and retraining. AutoML really takes a lot of that heavy lifting for you and kind of simplifies life a little bit. Now, here's another view of this. Again, that model training process is not iterative like this slide showcases, but it does showcase well what AutoML takes care of, right? So that cleaning, formatting, transforming data all the way to training evaluation data, AutoML can take care of that for you. So at AWS, we have two services, one fully managed service called SageMaker Autopilot, another open source framework called AutoGluon that helps you with, gives you these AutoML capabilities and it does it in different ways. So with Autopilot, this right now works on tabular data. And AutoGluon, this can work on more than just tabular. It can do images as well. And there are pros and cons for both, and we'll talk about that. So the first thing, Autopilot, this actually lives into a service we have here called SageMaker Studio. And you can see it on the right-hand portion of this slide. This is essentially an IDE for machine learning practitioners. It gives you one single pane of glass where you can work on notebooks, check out how your experiments are doing, be able to debug your models, take advantage of Autopilot, which we'll showcase in a second. And also, once you deploy that, be able to monitor and see how it's working with real-life data. So this is pretty simple to use. All you do is provide some sort of tabular data sets. You just tell Autopilot which column you want to be able to predict on. You go ahead and create that model, and you can track how it does. You're seeing on the right-hand slide over there how the UI looks, but I'm going to get out of my PowerPoint presentation over here for this and actually just showcase this in person. So what I'm going to do right now is just drag and drop my browser onto this screen. Hopefully everyone can see this. Ron, let me know if someone can't. Let me try to make this a little bit bigger to make it easier to read. But essentially what you're seeing right now is the AWS Management Console. And if you're not familiar how to get here, essentially you just go to console.aws.amazon.com. That'll load up the Management Console. I'm logged in right now in my demo account for the purpose of this presentation. And the first thing we're going to do here is go to SageMaker. SageMaker is our service that makes it easy to build, train, and deploy machine learning models. We're going to click on that top link over here called Studio, which is the IDE for this. And it's going to say which user do you want to log in under. So I'm just going to say this first one over here and open up the Studio. This is going to now go ahead and load up the Studio interface, again, which is that IDE. Once it loads this up, I'm going to go ahead and just say I want to create a new Autopilot experiment. So over here, you can see this interface. I can click on the right now and say build models automatically. I'm going to just click on this button, create Autopilot experiment. Now you're going to see this UI similar to what it was on the slide. and it's going to ask for a little piece of, a couple of pieces of information here. So let's just break down the scenario what we're going to use Autopilot for. I have this tabular data set over here in Microsoft Excel. And essentially, this is something like 41,000 rows of customer data. This is all synthetic. This is just generated for the purpose of this demo. But the idea of this here is these are customers of a bank, and we mark down whether they accepted a marketing offer that the bank put out, right? So the rightmost column over here is if the customer said yes or no. All of the other columns here are different details of the customer, their age, their education, and other little different pieces over here, how you can get in touch with them. And then at the end over here, you can see whether they accepted that marketing offer or not. Now, the idea of this is we want to be able to put the pieces of data of a new customer and get back the results. Are they going to accept that marketing offer or not? And this is what we're going to use Autopilot for. So let's go ahead and just create a quick Autopilot job here. We can call this AngelBeat Bank ML. From here, we just have to give a name for where we're going to store this data, where it's going to be able to see that Excel data, the tabular data that I just showcased. I've already gone ahead and uploaded it to this bucket over here called AIML-data. And then I'm going to put the name of this over here. So this is called bank-additional.csv. This is the tabular data set that I just showcased. Next, it's going to ask for, well, first, right below that, it's going to ask for, is this input a manifest file? It's not, it's just a CSV file. A manifest file is another file that links to multiple files. This is not that. It's going to ask you, what's the target attribute? We're going to say Y. That is the attribute that we want to see. So again, if I drag back my Excel sheet over here, this last column, it's called Y over here, and that says, is it no? That just specifies if they accepted or didn't for the bank offer. Okay, and now it's going to say, where do you want the output? We can go ahead and say, put that back in the same place. Excuse me. And then from here, select the machine learning problem type. This is going to be binary classification just because we just want to get a simple yes or no. But for now, I'm going to say leave it automatic. It'll figure out itself whether it's binary classification or not. Again, it also does regression, which again is continuous values. If, for example, you want to predict temperature or forecast stocks or something like that. The other option here is multi-class classification. Again, this is just binary classification. Do you want to run a complete experiment? Yes or no? Right now, we're going to say yes. No is interesting. If you say no, Autopilot will showcase insights into your data, and it'll also give you insights into which types of algorithms it would use to train models for your data. So this is not a black box. Most AutoML functionalities that you see in the market is a black box where you don't see how it's thinking, the inner workings of how it's actually creating that model for you. That's not the case for Autopilot. It'll actually walk you through that thought process over there, so you can actually learn from this as well. And no matter what, you have the option to see that inner workings of how that comes. But if you say yes, it'll also create the model for you. If you say no, it'll just create those insights for you. So right now we're going to say yes. We're going to go ahead and create that experiment. Now it's going to go through these these three pieces over here. It's going to analyze that data. It's going to do the feature engineering for you, and it's going to do the model tuning for you. Then it's going to display a list of models over here. Now, like any good cooking show, I've already have this completed. And basically to see this, it's a little experiment, SageMaker experiment list over here. I've already clicked on that. We can see a past experiment that I've done. I'm going to go ahead and say, showcase that. And you can see that this is that same exact, the same exact model was created for that same exact data set. Let's go ahead and sort this by the accuracy here. We can see that in this case, this was the best model over here. And now over here, once we have this, we can go ahead and deploy that model. Once you go ahead and deploy that model, you can just give it, create a name for that endpoint. From there, you're going to say what responses do you want back from this? Do you want just a predicted label? Do you want the probability? And so we can add more data for that. Again, once it deploys, this deploys as an endpoint, and then you can access that like any other endpoint, and that's Autopilot. This is pretty simple to use. So let me go back to my presentation. Oh, so one thing I forgot to mention, I spoke a little bit about this. Let me go back to my browser here. So once it creates these models for you, again, it has these two little buttons over here where you can open up two different notebooks. The first one is, I'm sorry, the second one over here is a data exploration notebook where it'll give you an analysis of that data set. And then the other button over here is the candidate generation notebook. The candidate generation notebook will just give you a description of all the different types of models and algorithms and hyperparameter ranges that it's going to run through to create all the models that we just saw over here. So that's Autopilot. Let me go back to my presentation. Now the next thing over here is Auto Glue On, right? So Autopilot just works on tabular data, kind of like I showed you with that Excel sheet. Auto Glue On works for more than just that. You can do tabular data, you can do image classification, object detection, text classification. The idea here is simplicity, right? So you can see with the lines of how many lines of code it needs to go ahead and train a model with Auto Glue On. So this again is pretty simple to use. Now the difference over here is Auto Glue On doesn't give you that insights of what's happening behind the scenes. This is more of a black box where it'll go ahead and train everything for you. You have the ability to do now not only text, image, object, text classification as well, but you can't see what's happening behind the scenes. Excuse me. Okay, so we just saw that we just showcased this example over here, predict if the customer will accept the bank offer with Autopilot. Now with Auto Glue On, this is also, it gives you really accurate results. On the left over here, you see this Kaggle challenge, Auto Group Product Classification Challenge. This is something that finished a while ago, but using Auto Glue On, you can go ahead and you run it with that data set that provides you in the Kaggle challenge, and it'll put you in the top 1% for results, which is kind of crazy. So this is a pretty accurate tool that you can use on to get some very highly accurate results. If you want to learn more about both of these services, there's a great blog post on Auto Glue On by one of my colleagues, Shashank. Definitely recommend checking it out. It'll showcase a little bit more on Auto Glue On, also showcase how a little bit more on how you can get in that top 1% of the Kaggle challenges with that. On the right-hand side over there, you can see more information on Autopilot as well, if you want to check that out. Okay, the other thing I want to mention here, right? So now with Autopilot, Auto Glue On, this is you're still training your own model. But now we also have ways where you can still add intelligence to your applications without training that model. And I'm going to touch on that in a second, but before I do that, I just want to showcase here the machine learning stack, and this is how we think of ML here at AWS. So it's 3 different layers. That bottom layer over here, these are the ML frameworks infrastructure. These are really for that advanced machine learning practitioners who are really comfortable on a framework level. We have teams dedicated to each one of those frameworks, TensorFlow, MXNet, PyTorch, to make sure it runs in an optimized way on the AWS cloud. You go one layer above that, these are our ML services. These are for your developers and data scientists. From here, this is our SageMaker suite of services, right? So these are services that make it easy to build, train, and deploy your machine learning models. We already took a look at SageMaker Studio, that IDE, and we'll take a look at another service in a second. And then that top layer, the top layer is models that have already been created internally here at Amazon, and we've opened it up as APIs for you to automatically add that intelligence into your application, right? So you can use that for vision, for speech, for text, for forecasting. You can also use it for fraud detection, which is really interesting, as well as for your actual code development with Amazon Code Guru. So you can use this in multiple different aspects of your in your applications. So let's take a look at one of my favorite services here, which is Amazon Recognition, right? And we're going to switch over to the console again, but just wanted to showcase the Python code here for detecting faces. This is something that's really easy to use and a lot of fun as well. So I'm going to go ahead and end my presentation here, go back into the console. Again, if you want to go back to the console, console.aws.amazon.com. Now we're back over here. I'm going to just search for recognition, and this will take us to the recognition service. Right now, I'm going to click on try demo just to showcase what this does. So basically, you can see right away, this does object and scene detection. Here's a sample photo. It'll showcase not only what's here, the car, but where are the cars in image. So both classification and detection. Here's another example of image classification. It's telling you what it sees in an image, building, city, town. This is great for organization for your photos as well as videos. Then we have another really popular use case here for recognition, which is image moderation. Is something safe for work, not safe for work? Facial analysis to give you details on what it's seeing on a face. You can get to see things like smiling, the emotions, are they wearing glasses or not, etc. But one of my favorite services here is custom labels. Now with custom labels, this is, let me showcase a project that I've built earlier. So let's go to card detection and we'll say view test results. So here, that's me, and that's me holding cards. There is no machine learning aspect of me kind of training a model for this. This is just me in the interface drawing bounding boxes on my data set. And then from there, I just click on train a model. There's nothing else that you need to do, right? You don't need to have that machine learning expertise to be able to create that object detection model for you, right? So in this case, what I did was I took a QuickTime video of myself holding a bunch of cards to the camera. I broke that down into frames, and then from there, I went ahead and labeled that with a tool called Ground Truth, which we'll talk about right after this. And then it just created a model for me. This model lives as an endpoint. I can pass it on photos, and it'll showcase which cards I'm holding, right? So in this case, this is one where it just sees right away that this bounding box with the 0 here, the 0 means 6. So you can see 6 and 10. It's able to see it even though it's not that clear as well. So it's pretty accurate. It works really well. It's very simple to use, and you don't need that machine learning expertise to create models like this now, and it's called custom labels. So now there's one last section over here in the presentation that I want to talk about. We just touched upon it a little bit. It's that data labeling portion. I would say that this is the least sexiest tool here for machine learning, but it's also my favorite at the same time. And that's essentially because when we talk to our customers, we see that 80% of the time it takes to deploy a model actually comes from that data labeling portion. It's not fun, but at the same time, it is a problem. So we introduced a service called Ground Truth, and it does a couple of things here. It has UI, a great UI that makes it really easy and quick to train your data sets. It has integrations with different pools of human labelers. It also has the ability to give you accurate results as well as in a cost-effective way, and we'll just touch upon these points in the next couple of slides. So it has pre-built labeling workflows. So it makes it really easy for your labelers to create bounding boxes, to do image classification, to do semantic segmentation if you want to know on the pixel level where an object is in an image. Also text classification as well. And just in case there is some type of data labeling you want to get done that's not part of our UI flows, you can easily use our components and create a custom workflow. And I've seen people use this, for example, audio classification. Now, the next thing it does here is it lets you select a pool of labelers, right? So Amazon Mechanical Turk is a workforce of 500,000 strong. It's really fast for labeling. This is great for non-sensitive data, and it's actually pretty cost effective. I've used it for some of my models as well. But now there are definitely instances where you require subject matter expertise or you have sensitive data. In that case, you can actually take advantage of Ground Truth and use your own in-house workforce to label that data. And then you can also take advantage of other third-party partners and vendors who have different types of subject matter expertise or support plans that you might like. Now, the other thing I mentioned too is that this helps with that accuracy of labeling. So if I was in the room with everyone here right now, the first question I would ask everyone is, what type of dog do you see over here? You get back a couple of responses. In this case, for this particular example, we have 4 people who are going to be labeling this data set, which is just this one image. You see what the first person says bulldog, second person says Shar-Pei, and the last 2 say bulldog. This is actually a Shar-Pei, but because in this case we're doing majority voting, this comes out to be a bulldog, which is not correct. So with ground truth, you also get the ability to take advantage of probabilities and the Bayes theorem. Specifically, we're using something known as expectation maximization. And in this case, you're taking a look at the accuracy of these labelers as well. And now you're seeing that in this case, even though only 1 out of 4 people said Shar-Pei, Shar-Pei was actually the correctly labeled answer here. And if you're interested in learning more about how we're using that specific algorithm here, here's a link over here that you can feel free to check out and how we're taking advantage of expectation maximization for that accuracy. And the last thing I want to touch upon is that cost effectiveness, right? In this case, you have a large set of data over here, and you want to send that obviously to labelers. In this case, it's going to be drawing bounding boxes for object detection, what I assume is for animals in this case. Now, obviously, with large data sets, this, while necessary, is still costly, right? One of the things that ground truth does is during this, you can also do active learning and auto labeling. So during this time when labelers are actually labeling that data, it's also training a machine learning model with that data. From there, after I believe it's 1,000 inputs are labeled, it starts shifting and sending that input data to your model and then starts labeling it. However, if it's not, if the accuracy is low, it'll go back and send that back to the labelers and do that process until that accuracy actually is high for that computer vision model to just auto label your data. And you can modify that accuracy for whatever you feel comfortable as well. So that is primarily AutoML here, and one of my other favorite tools, ground truth here at AWS. I hope everyone here enjoyed this. This was one of my favorite services that we have over here. If you have any questions, feel free to reach out.